We continue our examination of measures of spread by looking at data that are symmetrical. In other words, this data is not skewed. Then the mean and standard deviation can be used to describe the spread of the data. If your data are not symmetrical, then you need to use the 5-number summary that we just discussed. The standard deviation, in a nutshell, is the average distance of the data points from the mean. So there's a method that you use to find the standard deviation, and we'll go through an example so that this will make more sense. First thing that you have to do to find the standard deviation is to compute what's called the variance. To get the variance, you find the mean of your data, that's just the average. You add all of your data values together and divide by the number of data points. Next, you subtract each data point from the mean, and then you square that difference. Third step, you add the differences together, and then you're going to divide that number by 1 less than the number of data points. That value is the variance. To get the standard deviation, you take the square root of that number. Well, how can you use the standard deviation to describe the spread of data? Okay, well, this is known as the standard deviation rule or the empirical rule. For a normal distribution or a bell-shaped curve, so let's say if you graph your data, the distribution looks something like this, which would be a bell-shaped curve. If that's the case, then the mean is going to be the value that's in the middle, and mean is often denoted as x bar. Well, 68% of data will fall within 1 standard deviation of the mean. So that means if from the mean, and let me make my font a little bit smaller here. If I take my mean and I subtract 1 standard deviation, and then if I also take my mean and add 1 standard deviation, then all of the data that lie between these values will be 68% of the data. Okay, well, what if we looked within 2 standard deviations of the mean? So if we had x bar our mean minus 2 standard deviations, and we're also going to look above something bigger than our mean plus 2 standard deviations. So if we look within 2 standard deviations of the mean, we're actually going to have 95% of the data appearing there. And well, let's go one more step, and let's say 3 standard deviations from the mean. So if I do 3 times the standard deviation and subtract it from the mean, and also do 3 standard deviations plus our mean, well, you're going to find that you have 99.7% of your data falling within that range. Okay, so let me write that down here. So 99.7% of your data will fall within 3 standard deviations of the mean. Okay, so we had 95% are within 2 standard deviations, and 99.7% are going to be within 3 standard deviations. Okay, and this is something that you want to keep in mind. And we'll have some examples on the next page. In the next example, Okay, we have the level of phosphate in the blood of a patient in milligrams per deciliter of blood on 6 visits to the clinic are, and we have these 6 measures. And we're being asked, what is the standard deviation? Okay, so we're going to go through that process that I outlined earlier on how to find the standard deviation. So the first thing I want to do is to find the mean. So to get the mean, we just add all of those values together, which will give us a 32.4, and we divide by the number of values, which is 6, and that gives us 5.4. Now the next thing we need to do is get the difference between each of our data values and the mean, and then we're going to square that value. Okay, so let's start with our 5.6 minus our mean of 5.4. Square that number. So that's going to be 0.2 squared, which gives us 0.4. Okay, our next data point, 5.2 minus the mean, which is 5.4, squaring that. So this gives us a negative 0.2, and we're squaring it. Squaring a negative makes it positive, so we also get 0.4 in this case. Our next data point is 4.6 minus our mean of 5.4, and we will square that value. When we get that difference, it's negative 0.8, and when we square that, that'll give us a positive 0.64. Okay, next we have 4.9 minus our mean of 5.4 squared, and that's going to equal a negative 0.5 squared, which will give us a positive 0.25. 2 more to go. We have a 5.7 minus 5.4 squared is going to equal positive 0.3 squared, which will equal 0.09. And then our last data point, 6.4 minus our 5.4 mean squared, and that's just equal to 1 squared, which is equal to 1. Okay, so now that I have found the difference between my data points and the mean and squared the difference, we now need to add all of those values together. And when you add those together, you should get 2.06. Okay, so now our third step, we need to take that value of 2.06 and divide it by the number of data minus 1. So we need to divide it by 5. And let me do that in my calculator. Divided by 5 gives me exactly 0.412. So this value, if you remember, is the variance. So our final step to get the standard deviation is to take the square root of that number. So that'll be the square root of 0.412. And let's round to 3 decimal places, should give you 0.642. Okay, so what does that mean? Okay, well, with a mean of 5.4, the average distance of any of our data points from the mean is going to be 0.642 units.